We now talk about electric flux through a cube of side A. So first note that if this small surface vector ds vector is perpendicular to the electric field, then the electric flux, which is given as E vector dot product with ds vector, which is E ds cos theta. Now since cos theta is 0 for theta equals to 90 degrees, so the flux would be 0. So we need to consider faces which are not perpendicular to the electric field, because the faces which are perpendicular to the electric field would have flux as 0. So let us first find out which faces are perpendicular. For that we will just put flux as 0. So say this is the electric field. So first we start with the top face. You see top face is perpendicular. So you have the surface area first. You have small surface area here ds. So ds vector is perpendicular to the surface area. So ds vector is perpendicular to the electric field. Similarly for bottom face, you have this small ds area. You have ds vector perpendicular to this area and therefore perpendicular to the vector field. Now you talk about front face. Again you have ds vector here, which is perpendicular to electric field. And then you have back face. Again you have ds vector which is perpendicular to the electric field. So the only two faces where ds vector is not perpendicular is the left face and the right face. So let us write this down. Top face, bottom face, front face and back face, all of them are perpendicular to electric field. So we have ds vector is perpendicular to the electric field. Notice that ds vector is again perpendicular to the surface area. Now the right face and the left face. So here the ds vector is not perpendicular to the electric field. So left and right face will have non-zero flux because they are not perpendicular to the electric field. So let us start with the left face. So the flux is given as the surface integral of E vector dot product with ds vector. So this is E ds cos theta. Notice that we are talking about the left face. So ds vector and E vector are pointing in opposite directions. So the angle between them is 180 degrees. So again we are talking about the left face. ds vector and E vector are pointing in opposite directions. So angle between them is 180 degrees. That means theta is -1. So the integral now becomes minus E ds. Since E is independent of the surface area, you take minus E outside and then you integrate over the surface area. So since this is a cube of side A, the left face has area A square. So we have computed the flux through the left side. It is minus EA square, where A square is the area of the left face. Now we talk about the right face. Again we copy down the formula of flux, which is surface integral of E vector dot product with ds vector. This is equal to E ds cos theta. Now ds vector and E vector are pointing in the same direction. So since they are pointing in the same direction, theta is 0. So therefore cos theta is 1. So you get E integral of ds, which is equal to EA square. So what is the net flux? So now net flux is sum of all four faces. So you take left face plus right face minus EA square plus EA square. Then you take top face, bottom face, front and back. All of those have 0 flux because their surface area is perpendicular to the flux. So even if you calculate the integral, you will take theta as pi by 2. Now you take the sum, it is 0. So net flux through a cube of side A is 0.